Today you're going to be filling in a foldable on completing the square, because after you fill in the foldable, you're going to be doing two activities to help you remember how to complete the square, because we're going to need to understand it in order to help us with parabolas and putting them in graphing form. So in order to complete the square, it's a 5-step process where step 1 is if a is not equal to 1, we're going to divide both sides of the equation by a. That's like in this example right here. See, a is 2. The next step was to take it and divide it all by 2, because x has to be just x squared. If that's not true of x, we just go on to the next step. Next step is to rewrite the equation so that the constant term is alone on one side of the equal sign. So add or subtract something to get the constant all by itself on the other side. Step 3, we're going to change slightly. We're going to use a generic rectangle to help us, because this is the step you really complete the square. Step 4, we're going to factor the resulting trinomial into a perfect square and combine terms on the other side. And then the last step, we're going to use the square root property to complete the solution. So in this first example, we have x squared minus 12x plus 20 equals 0. Since there's nothing in front of x squared, we're just going to subtract 20 from both sides. And now we have x squared minus 12x equals negative 20. So now what we're going to do is we're going to complete the square. So we're going to draw a generic rectangle. And inside our generic rectangle, we know that this is x squared. I have to split the negative 12x in half. So it's going to become negative 6x in both of these. So then I know above it's going to be x and negative 6, x, negative 6. So to figure out what goes in the last square, or to complete the square, I'm going to do negative 6 times negative 6, which is positive 36. So now when I rewrite my trinomial, I get x squared minus 12x plus 36 equals negative 20 plus 36. So now I rewrite this as a perfect square. So I'm going to rewrite it as x minus 6 squared, because it's x minus 6 times x minus 6, equals negative 20 plus 36 is 16. So now I'm going to use the square root property to take the square root of both sides. I know that the square root of a square is just itself, so I get x minus 6 equals plus or minus 4. And then I add 6 to both sides to get x equals 6 plus 4, or x equals 6 minus 4. So my answers are 10 and 2. In my next example, my square is not as perfect, so I wanted to show you one where the ending result is going to be a radical expression. So x squared minus 5x minus 3, still nothing in front of x squared. So the first step is to add 3 to both sides. So I get x squared minus 5x equals 3. So now I'm going to draw my generic rectangle again. This time I have x squared and negative 5 over 2 x in both of these, because I'm dividing 5 in half. So then I have x minus 5 over 2, x minus 5 over 2. So in order to figure out what goes in my square box, I multiply them together. So I get negative 5 over 2 times negative 5 over 2 is 25 over 4. So that's what I'm going to add to both sides. So now I get x squared minus 5x plus 25 over 4 equals, and I'm going to change the 3 so it's over 4. So I have 12 over 4 plus 25 over 4. So then I simplify. So I get x minus 5 over 2 squared equals, and this ends up being 37 over 4. So then I use my square root property. I square root both sides. So I have x minus 5 over 2 equals the square root of 37 over 4, plus or minus. So I'm going to add 5 over 2 to both sides. So my final answer is just going to be x equals 5 over 2 plus or minus the square root of 37 over 2. Because I can take 4 squared rooted is 2. And this is my final answer. The last example is 2x squared plus x minus 6 equals 0. So this time I do have a number in front of x squared. So first thing I want to do is divide everything by 2. So I get x squared plus x over 2 minus 3 equals 0. So then I still add 3 to both sides. So I want my constant term. So now I have x squared plus x over 2 equals 3. Now I draw my generic rectangle. I have x squared. I have half of x over 2 is 1/4 x. Because half of 1/2 is 1/4. So then I have x plus 1/4 and x plus 1/4. So together 1/4 plus 1/4 is 1/16. So that's what I'm going to add to both sides. So my trinomial becomes x squared plus x over 2 plus 1 over 16 equals 3. I'm going to make it over 16 so that I can combine them together. So I would end up with, so 3 times 16, 28. No, 3, 48. 48 plus 1 is going to give me a 49 over 16 when I do that. So now I get my perfect square. So I have x squared plus 1/4 squared equals 49 over 16. So when I take the square root of both sides, notice that it's not a perfect square by itself, but 49 over 16 are two sets of perfect squares. So when I take the square root, I'm going to end up with x. This isn't squared anymore. It should just be x. X plus 1/4 equals plus or minus 7 over 4. So then I subtract 1/4. So I get x equals negative 1/4 plus or minus 7 over 4. So when I simplify that, negative 7 plus negative 1 plus 7 is 6. So x equals 6 over 4 or 3 over 2. Or negative 1 minus 7 is negative 8. Negative 8 over 4 is negative 2. So my answers are 3/2 or negative 2. So make sure that you filled in your whole foldable and that you understand completing the square. You can now work in your groups to finish the 2 activities.